Hi folks, this is AAT Section 1-6 Absolute Value Functions, also a review from algebra. When you take absolute value of a number, you always end up with a positive number, or 0. For instance, if the absolute value of x equals 3 implies that x was either 3 or it could have been negative 3 to get out that positive 3, since these are both true. When solving an absolute value equations, we need to set what is inside the absolute value symbol equal to the given number and its opposite. So just like we see here, we have to set x equal to 3 or negative 3. So this means whatever is in the absolute value equals a means that square is going to equal a or the opposite of a, whatever's in the absolute value. You will get two answers unless unless it is a set equal to 0, one answer, or no solution. If the set is equal to a negative number, you'll get no solution. So let's try a couple of these. Solve and graph your solutions. First thing when you're solving absolute value equations is to isolate the absolute value. So we want to get it by itself first. So to do that, we need to divide both sides by 2 and we need to subtract 7. Of course, we know our order of operations on equations. We got to get rid of the 7 first. So 2 absolute value of x equals 11 minus 7, which is 4. And then to get the absolute value alone, that's multiplication, so the opposite is divided by 2. Which gives us the absolute value of x is equal to 2. Now we separate it to two problems, not until that absolute value is alone. So what's in the absolute value is going to equal to 2, and what's in the absolute value could have been the opposite of that, negative 2. So to plot it on a number line, let's just put in a couple numbers here. We got our negatives and our positives. Go all the way to 3 and negative 3, so our answers are dot on negative 2 and positive 2. Okay, so next, solve and graph your solutions. Same idea, we got to get the absolute value alone first. So what am I doing to absolute value x? I'm multiplying by 3, I'm dividing by 7, and I'm adding 6. So I'm going to start by getting that 6 to the other side. Remember, this is just our little equation line here. So this becomes 0. 3 absolute value of x over 7, which is the same thing as just 3/7 x equals 0. So the opposite of multiplying by 3 over 7 is to divide by 3 over 7, which means to multiply by the reciprocal. So we're going to flip over that 7/3 and multiply it to both sides. So of course 3's are gone, 7's are gone, because to multiply that we just get 1. And 0 times 7/3 is 0. So absolute value of x is equal to 0. So when we try to separate that into two problems, well, x can't be 0 and negative 0. So we just have one single answer. That's the one time when we have one answer, is if the equation, if the absolute value ends up equaling just 0. Let's plot it as a single point. So solve and graph your solutions. First, we isolate the absolute value. I never went to 2. Then we separate into two problems. Don't forget to do that. Okay, so here, absolute value is already by itself, so we can go ahead and separate this into two problems. So x plus 3, what's in the absolute value, is going to either equal 5, or x plus 3 is going to equal the negative 5, the opposite of that. Subtract 3 from both sides. Here we get x is 2. Subtract 3 from both sides. Here we get x is negative 5. So negative 6, negative 5, 4, 3, 2, 1. 0, 1, 2. So I'm going to put a dot on 2 and negative 5. Always put a little box around your answer so we can easily find it. Awesome. Moving on. When solving an absolute value inequalities, so now we have less than and greater than, you need to understand two possible cases. If you have the absolute value is less than A, it means this, remember we used to say in Algebra 1, less than. That's an and statement because it's less than some distance from 0. Remember, absolute value means some distance from 0, like the absolute value of x equaling 3 means you're either at 3 or you're at -3, and that's the distance you are away from 0. Well, if you're less than that distance from 0, you're either less than 3 or greater than -3, so you're between two values. You get this betweenness going on. So when you see a less than, you're going to make it an and statement. X is greater than -A and less than A. Make sure these go in a direction that makes sense. Case 2, if you have a greater than, it is greater than some distance from 0. So like it's out here, greater than the distance of 3 from 0. So it's either greater than A or, and you should have the word or, less than -A. So here, this is an and statement. And means betweenness. So 5x plus 2 is between 7 and -7. So make sure the 5x plus 2 is greater than the -7. It's on the greater side, and less than the 7. So to solve a compound inequality, we subtract 2 from all three parts. And we get -9 is less than 5x is less than 5. We're trying to get x alone, so we divide 5 to all three parts. And this becomes -9/5 is less than 5 divided by 5 is just x. And 5 divided by 5 is 1. So -9/5 is the same thing as -1 4/5. So on my number line, here's -2, -1, 0, oop, doesn't quite fit, and 1. Get another color here. So at -1 4/5, -1 4/5 would be about there. And +1 would be up here. Now you got to pay attention if it's open or a closed bubble. If it's a greater than or less than, it's going to be an open bubble. We talked about this already because it's not including. And if it's greater than or equal to or less than or equal to, it's going to be closed because it's going to include it's equal to that point. So I actually should have made these, they're not equal to those values, they're open circles, not equal to. And we're shading the area between them because the solutions are actually all the numbers between -9/5 and -1. So an and should look like this betweenness going on, two things going towards each other. So here we've got an or statement, a greater. So we're going to write 4x minus 5 is greater than or equal to 15, just like we see it. Or 4x minus 5, since we're going to make this the opposite sign, we've got to flip to the opposite, less than or equal to -15. Okay, so we're going to solve these two. Add 5, 4x is greater than or equal to 20, divide by 4, x is greater than or equal to 5. Or, don't forget to bring that or down. Add 5, 4x is less than or equal to -10. Divide by 4, and you get x is less than or equal to -10/4. And 10/4, I can simplify, is 5, -5/2. So, or x is less than or equal to -5/2. Okay, so we got -5/2, which is -2.5. So I'm going to start negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5 up here. And it says sorry, froze there on my computer. It says either that we're going greater than 5. So greater than 5 is this direction. And it's closed this time because it's equal to, so that's a closed bubble. Greater than or equal to 5, so I'm going to shade that way. Or it's less than or equal to, closed again, negative 2.5 or negative 5/2. So that's what it should look like. Okay, last one. This one has a little fraction action on it. It's isolate the absolute value. Absolute value is already alone. So we're going to separate it to two problems. This is a and, less than, so it's a compound inequality again. So 1/3 x minus 1 is between 2 and negative 2. Okay, so we write what we see, but we also make sure it's greater than the opposite sign. So same thing to all three parts of the inequality. Add 1, add 1, add 1 to get that x alone. So I get negative 1 less than or equal to 1/3 x less than or equal to 3. Okay, how do I get rid of a 1/3? I basically flip that fraction. I'm going to multiply everything by 3, or 3 over 1. So 3 times negative 1 is negative 3. Less than or equal to 3 times 1/3 x is just x. And 3 times 3 will be 9. So this x should be between negative 3 and 9. So negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. These are closed bubbles because it's equal to, so I need to include those values as part of the solution. Whoops, should be over here. I'll get a little white out on that 4. Not there. And I'm going greater than negative 3, and it's an and statement, less than 9. So it's all of this. All right, great job. Try some on your own.